Okay, it's recording. Hello. Okay. Hey, hello and welcome to the Slack Chat podcast. So this is a podcast about the Slackware Linux distribution and in particular Slackware on ARM. And we're really talking about developing it, using it, and we're evangelizing it a bit. And also we're talking about how, the way it links into the wider open source community. It's a way of bringing people into the community. It's also, in a way, a bit of a podcast blog as well, as we'll talk about in a moment. So I'm Stuart Winter. I'm the architect and developer of the ARM port of Slackware. Hello. And we've got Phil, who's the maintainer of SARPy, which is the community project to bring Slackware on Raspberry Pi. Hi, Phil.
Hello, Stuart.
How are you doing? You all right?
I'm very well, thank you, on this glorious sunny day.
It's a nice weekend. All this coronavirus stuff, we're all in the house. We just started doing it this week, actually. Mm-hmm. So it's going to be an interesting time. It's actually funny. It's got me thinking about. I'll tell you in a minute. Actually, I've been thinking about what I'm going to use Slackware for next. I've got a work project to do with Python and some of the APIs on our platform. So I'm going to use one of my Slackware ARM boxes to start experimenting with that and learn a bit of Python and play around and approach the platform and the product from a different direction. Because that's kind of where the whole thing's going, really. Yes. The automation side. And so, yeah, I'm going to gen up on that. Start working on that.
Really interesting.
It will, yeah, I hope so. It's going to be, so I haven't done anything. Because I was thinking, I haven't done anything sort of technology-wise for ages. It feels like ages anyway. I've got a number of things to do for the Slackware ARM port. I want to update the installer so that it detects whether your system time is wrong, like it does in Slack package. I want to just take the code I put in Slack package, which is actually one line of code. But actually for the installer, I need to do it a bit more complex. I want to add in, if it detects you're in 1970 at the epoch of Unix, then if there's networking support, go and offer some NTP server so that you can set the time in the installer. And then if there isn't, then bring up the networking screen to go and get networking. I've got that planned out. I just haven't written any code to do it yet. But yeah, so I want to do that because it actually sounds straightforward, but it's not as straightforward as it's not like a 10-minute job because in the installer, I don't know if you know, but it actually reverts what would you say? It turns the clock back a little bit
to 1970.
No, it doesn't do that. It turns the clock back by a small amount of time. I think it's a day or it might be an hour. I don't remember the time now. It helps prevent the file system checks when you first boot the OS in case there's some weirdness with the time. There's a script in the installer that does it. I think it's called fake date or something like that. So I need to get the NTP date, then fake the date back, reset the clock back a bit. There's some documentation around that. I want to spend some time on looking at some Python stuff and then start using my Slackware desktop to do that and do some customer work at the same time. So that'd be quite a nice blending of two interests there. I made a post on Twitter the other day because I woke up on Monday and I was thinking, right, this is our first self-isolation thing going on in the UK. And then I was like, okay, so I got up in the morning, went to start doing my exercise, before everyone gets up. As I was just preparing, I do exercise to some music so I can sort of get a rhythm of exercise. I find it kind of works quite well. I thought, I'm just setting that up. I just thought I'll download this latest updates for current so I can set the ARM box processing them. I went to my distribution scripts directory and I did /f and I went to press tab, the double tab. There's nothing coming up. And I knew what was wrong. Have you ever had that time when you know something's wrong, but you don't, and you know what it is, but you don't want to believe it's true yet because it's that bad?
Yeah.
It was kind of like I was teetering on the edge of going, no, I'm not going to commit to this. No, it can't be that. And I was like, doing it again, /f, tab, nothing comes up.
Yeah.
Like, this is not good news. When that means, it means the file system has died or something bad has happened to that. And so I was like, okay, dmessage. Oh dear. The dev SDD write sector reads errors all over dmessage. And that was the drive with Slackware ARM on it. The whole thing was that drive. And I was like, that's really not what I wanted to see this morning.
Yeah.
And so I had to... Oh, that's right. Yeah, So that, oh yeah, there was the two failures in a row. So that happened. So, and I'll talk about that in a moment actually, because that was quite interesting.
Uh,
So the fortunately I was able to bring the disk back. So I've got spare disks around. So it was, so and the entire Slackware ARM tree, like the master tree with all the other bits that aren't public, even that's only about 70 gigs. There's loads of stuff in there, like from the year dot, and so all of that's in there. So I pulled out another disk and I got the shut the machine down. Then fortunately, one of my old colleagues where I used to work years ago, when I was a sysadmin, we used to he'd set up our snapshot, and then the tape device would come along and pull the snapshots and just write them to tape. So I've had our snapshot running for years, and I have, because of Slackware ARM, I have it running on. I have backups on the hour. So every hour it does a fresh backup on my server, where the main x86-64 Slackware server on there. So it backs up everything on the hour, which is, to me, it's pretty good actually. I mean, if you were doing a lot of development, you'd lose what you did for sure. But fortunately, because only GCC was building at that time, that was the only thing changing on the entire of the Slackware ARM master tree. So I didn't lose anything apart from GCC. It already gone through once anyway. So the first pass was done. It was the second pass. So I lost the second pass. So I just started up again. I recovered everything from an R snapshot, which took about 20 minutes. And that was it. I just carried on from where I left off. I was thinking, thank God it was only the Slackware ARM disk and not the operating system disks, because that would have been, a bit more effort. But I was really pleased because, you had that feeling that I've basically just lost work. I've been running for like 17 years. I was really pleased that my sysadmin days, my habits of a lifetime, I've just kept them and set up, and you can actually recover really quickly.
yeah.
But then the week before that, because we haven't spoken for a couple of weeks, we had a power cut, and when you have the power and it cuts, and it's okay, the power cut, you lose whatever, but when the power comes back on, and then it goes off again, and then it comes on again, and then it goes off again. That's the kiss of death for hardware, isn't it?
Yeah.
Right.
Yeah.
And I was like, oh no. So whenever that happens, I usually try and rush to the main circuit, the electrical circuit board in the house, and switch everything off, because I don't want that kind of they're not power surges, but that frequent stop and start pattern is. So I usually do, but I didn't get a chance to do it, and so I came in to find one of my my Slackware ARM gateway machine. It does all the internet. It wasn't booting anymore. So the machine tries to boot, and the SSD was just going like. Actually, it wasn't an SSD. It was a 2.5-inch spinning disk, an eSATA spinning disk on my Banana Pi. And so it was U-boot was booting, and the disk was just going.
Yeah.
So that I couldn't get the machine booting. And so I thought perhaps the disk is broken, but I thought, okay, well, it's not going to be the end of the world, because that's backed up every hour as well. But then I discovered, so I thought, well, okay, how am I going to get the data off? So I took the disk out, I took it off the Banana Pi and put it into a USB caddy, because I thought I'll just see if the disk is broken, just see if I can recover something off of it, because maybe I can get the majority and I can restore the rest from the backup, because it's probably easier that way. At least I haven't lost as much, because that machine does do it's email server, but does web server, other things. So I would have lost stuff for sure. So I thought, well, let's try that. And it turns out that the disk was fine. It didn't have any errors on it once I connected it to an x86. And I thought, So, but the Banana Pi is booting, but the disk isn't working. So I was thinking, this reminds me of a power supply issue it seemed to be prevalent on Banana Pis in particular. And in fact, Shiva plugs as well. I've noticed a lot of this ARM stuff has really poor power supplies. And it's always been this way. Not on the Acorn, it wasn't. It had a really nice big fat power supply. But all the stuff I've got from ARM over the years, they're just cheap power supplies. And even though they continue working, and you can measure the voltage on them, they seem to be. I don't know enough about electrics to know what the problem is, but there's something wrong with them. I don't know whether they're not regulating it properly, or what happened. So in the end, I cut off. I looked at I turned the disk over, and I thought, well, this thing is being powered from a Banana Pi, which is only on a 5-volt output.
Yeah.
I thought, well, hang on, what's the disk take? So I looked at the disk, 5 volts. I think, oh, okay. So you've got loads of USB cables, chop one off, cut the little USB SATA cable on the Banana Pi, took the power, just cut the power bit off, soldered the wires together, and then just connected and soldered it onto a USB USB cable and plugged it into a USB
Yeah.
power supply. And so now the disk is powered independently from the Banana Pi, works perfectly. I didn't have
Cool.
to recover anything.
Yeah,
I
that's
was thinking
brilliant.
it's really good to know that because, if I hadn't have got all this extra kit, I would have thought the hardware was completely
Yeah.
ruined, but it's
Yeah.
not.
Yeah.
And I've done that with the Shiva plugs as well. I had to get and also the OpenRD client. They're the old Shiva plugs running off of an old monitor power supply that I bought off eBay. So it took me ages to get exactly the right power supply for
Yeah.
the 14 Slackware ARM 14.2 machine is actually being powered from an old monitor power supply I butchered, and then the Banana Pis have been powered from butchered USB cables.
Yeah.
So it's the actual hardware itself is good, but the independent power supply, no, it's worth knowing about that.
Power supply problems, I've had many, and of the type you describe, and often changing the power supply makes all the difference.
Yeah, I found the same. It's turned a machine that was stable, was previously stable, that became unstable, back stable again, just by changing the power supply.
Yeah.
So I think, people do know about that, or if they experience that, it's worth looking at some better quality power supplies that you can find. So maybe spend a bit more on a decent branded USB power supply.
It's definitely worth it in the end, I think.
I've got quite a few old Apple ones from old iPods and stuff when they made really big fat USB power converters. So I tend to use. I've still got a couple of those lying around that I tend to use. Those look pretty good. Yeah, so it's just been quite interesting. I've had some a bit of sysadmin work to do over the past couple of weeks.
Well, it's really great that you got everything working. It's impressive.
Yeah, it didn't take too long either. I've got to say though, I was a bit concerned because when I took the x86 server down, it hasn't been down in almost a year. The power in the area is pretty good. I'm thinking of getting a UPS actually now, but generally the power is really good here. So the servers don't get rebooted.
Yeah.
I went to go and shut the thing down to take out the broken Slackware ARM disk, and that was okay. I shut the machine down, but then it wouldn't power up again. So I pulled the front off. Well, I take the front off anyway because it's a proper server. It's got they're not hot swap drives, but they're on the sort
drive bays.
Drive bays, that's right.
Yeah.
So I pulled them out. But then I realised that somehow the front button had got bent. So so I was like, what? So I unscrewed that to try and figure that out. And I was really conscious, you don't want to start bending it back because usually these things just break, don't they? And I thought, but then it turned out, I don't know how it got like that, but so I pushed it back in again and I turned it on and the machine, it went, it powered up and then it powered itself down again. I was thinking, this isn't good, is it? So, but then I managed to fiddle around with the switch again. I thought it must be that the switch is kind of stuck on, I think. So maybe it thinks the machine, you're constantly holding it down and it's just turning itself off again. So I whittled the switch around a bit more and then managed to get I managed to finally get the thing to boot without the disk in. So I took out I put a new disk in as a replacement that I had and managed to get the thing booting. And it's funny because I left it, walked back to my office, and I set a ping going and started doing something else. And after about 10 minutes, it still hadn't booted. And I was thinking, give it a bit of time. It's x86. And after a while, I was like, I got that feeling of this isn't good. The machine's not booted.
Yeah.
And then I walked back to where it was. So, I went back, opened the doors. And then it was just getting to the login prompt. And I was thinking, what's happened to... And I suddenly thought, it's funny because it just made me realise that I hardly ever reboot my servers, the Slackware servers. I install them. This machine's been running 14.2 for years now, since 14.2 was released. Yeah. Hardly ever reboot the machine, never need to, yet I'd keep it up to date with all the packages. And I thought, it really just goes to show just how stable the distribution is. Yeah. But also how slow x86 server hardware is at booting and how fast ARM, because I'm used to ARM servers. I reboot my ARM machines all the time when I'm developing the distribution. And I'm so used to it booting within a minute or two. But x86 does all these checks on all these, all of the hardware. It takes forever. And I was thinking, do you really need all this extra? I know what it's for. I used to deal with this kind of stuff. So I know why you've got all the sensors and you've got, you can report back and you can run all the diagnostic tools. And I thought, but generally the hardware is so reliable anyway that I don't think you need it that much. Maybe I'm wrong. I know people would disagree with me on that, but like when you've got a machine that, like the ARM machine, has also been up for a few years, and I hardly have any problems with that apart from the power supply. But that's not that's a separate from the actual the device itself. And I was thinking, yeah, this stuff it's really stable. Like the ARM hardware is stable, the x86 hardware is stable, and so is the distribution. And it just made me realize I haven't done any of that kind of sysadmin go and fix it urgently stuff for so long. It's like, luckily I hadn't forgotten how to do it, but
Yeah.
I was thinking, I haven't done any of that kind of stuff for so long that it's made me think I need to get and start developing something and go and learn a new programming language. Because I think I was talking to one of my friends recently, and they were saying, who works as an architect in a DevOps team, and he was telling me that he was like, you can't rely on the old hardware, the old stuff that you used to know. It's good to, in the case of Linux, it's really good if you know how to do bash scripting. It's just really fortunate that the world has embraced all of that stuff. So if you know that, you can do a lot of stuff. But still, but bash only takes you so far, and so does Perl can take you in different directions. But a lot of the script, the example code and things, most of it's in Python, or a great bulk of it is at least in Python. And so he's like, yeah, you need to keep up on top of all this stuff. Like one of my other friends is learning Google Go. As I know, you talked about compiling the Go language.
Yeah.
But and Angel talked about it as well. There's so much that you need to keep on learning. It's kind of got me inspired to now everyone's working from home for absolutely ages. It's kind of got me inspired. Right, I'm going to set aside time now and start learning some of the learning more to go in that direction. Anyway, well that's what I've been up to. I know that you've been working on the Docker stuff, haven't you?
Yeah, we've just been doing that for, it seems like forever, but it's about a month now that we've been working on Docker.
So before we started recording the podcast, Phil was just showing me what he's been working on and how far he's got with Docker. So we are doing a screen share, SSH share actually, and which is one of the really cool things about Screen. I don't know if we were talking about Screen on the IRC channel recently.
Yeah.
Phil has allowed my server IP address into his, and then we've done Screen-X. So Phil's opened up a Screen terminal. It's called GNU Screen. So I use it for actually the Slackware ARM build system runs under Screen. Everything runs under Screen. It always has. You start your processes running, and then you what's called detach from it. In my case, what I do is I've got my x86 64 desktop machine, and then the actual Slackware ARM boxes are they're elsewhere, and I will occasionally crash the x86 machine. And if I didn't have Screen running, if I was just SSH'd in, I would lose the parent process under which the Slackware ARM build system was running. So that would have been SSHD, because that's what started all of the bash shell. So because my network connection would have died, the SSH connection, the SSHD on the Slackware ARM box would eventually realize, and it would kill off everything. So what I do is I've always run the entire build system under Screen. So what that means is if if I lose my connection to it or my system crashes, whatever, it's running completely independently. And it also means if I'm out and about, sometimes when I go away somewhere, if I happen to take the laptop, I might just go Screen-R, and I can see what the build system's doing at home. It's there's no difference between where I am. So I really like that, and that's what we're doing here with Phil as well. So Phil's opened up a Screen session and shown me what he's doing in Docker, and I've just done Screen-X to connect to it. So this brings me to the question, right? So last time on the podcast, we were talking about how to go and, really how to distribute it, weren't we? That was what you were going to distribute. And I was thinking about it since we'd spoken on the podcast, and I was thinking, and you've been doing the same kind of thinking as it seems, and it's really about what are you really aiming at? Because I thought to myself, after we talked about the mini root, and then we talked about the fact that Slackware really needs a set of it doesn't need this, but for new users, it's easier to have a full installation because things will just work.
Yeah.
Whereas if you do what I do on my systems, I trim it all down so that I don't have a full installation, because you just don't need a full installation really. But for new users, it's going to be helpful. But on the other hand, then I was thinking, well, like you said, Phil, you can't run an X session in Docker.
No.
So it just doesn't make sense to do it. If it was me doing it, I'd be building the container for a particular reason. Like I'd have a use case for it, and I happen to be going the extra mile to make what I've done consumable by other people. In the sense, like Slackware ARM is, right? I could have just kept it for myself, but instead I've written documentation about the hardware I happen to be interested in and happen to have purchased. And here's how you can do it too. So I've basically made my own methods and things available for other people, and that which takes more work. But the use case is quite clear. I wanted to build a distribution, and I like doing that, and I use it myself. But then in your case, because Docker isn't like that. Docker is, it's more of like the way I look at it is that the operating system in some respects is kind of irrelevant in a way, right? Because once you put out the Docker container, which I will call it the package if you like, because that's the way I look at it. Once you put that package out there, you can say, well, here's what you can do. You could say, I'm building software XYZ, and it does, I don't know, it's some kind of it's a thing that runs over the web, and it does this and it does that, and it does this and it does that. And it could be, for example, a webmail system. I'm just making it up, right, for the sake of conversation. But let's say it's a webmail system, and so you build your webmail system, you install all the packages you want in your Slackware container, and you say, here you go, here's the webmail system, it's version XYZ, and no one's particularly interested in what the operating system is underneath it. But your choice of operating system is because you fancy choosing Slackware ARM or Slackware. Yeah. And the users aren't too bothered about that. They get a deployable, I don't know if you call it, I don't know what the terminology is in Docker. It doesn't really matter. But they download it, they get it, and all they're really interested in is the fact that it's an appliance. It's kind of like having a toaster. Which capacitors you bought from what vendor is kind of like largely, I'm not sure if capacitors are in a toaster, but you get the idea. Like the components of, sorry?
I get the idea, yeah.
Yeah, I don't know. I just suddenly realised, wouldn't there be a capacitor in a toaster? I've never disassembled a toaster. Maybe I should. But anyway, we can say a monitor. There's definitely capacitors in there.
Yeah.
So, the users, I'm looking at my Samsung monitor and I'm thinking, I'm not interested in what capacitors are in there. I just want to look at what's on the screen.
Uh-huh.
And so I was thinking, what's your use case? Are you going to use the containers for something for doing the SAPI project, and you're going to make available the way that you build that project now, or what's the shape of it going to be like? Because I think that's the key thing as to what you distribute, right? Because I was thinking it would be better to distribute a full distribution, but then again, it's not useful, really, in some respects. But it's easier to maintain. But then again, I was thinking as well, you don't maintain the Docker image, right? You're not going to go in and update the Slackware packages inside of it, because the way I look at it is that if you want to do that, you update the master container, which has all the latest updates, and you distribute a new version, and they just bring up a new Docker container of the latest stuff. It's a different paradigm in a way, isn't it? I think that's the way I understand it.
Yeah. I mean, it's like if you were to put Docker in terms of real life, it's like when you buy a coffee from one of these coffee machines. You get whatever coffee they want you to have, and you get it in a cup that they give you. And when you've done with it, you throw it away. But when you're at home, you use your own coffee cup. So it's permanent. And I guess a Docker container is the coffee cup. Because once you've done with it, you throw it away. And in respects of what do I intend to do with Docker, with regards to Slackware ARM, we've done the building, the compiling in a Docker container, in a Slackware ARM Docker container, and that was with a SAPI build. And surprisingly, for whatever reason that I haven't investigated yet, it was quicker than compiling on a host system. And the package is installed and run just the same. There's absolutely no difference in that respect, but I'm interested to know why it was slightly quick. It was only, Out of 35 minutes it takes to build the kernel on a Raspberry Pi 4, it took 29 minutes in a Docker container. So that's the difference. Don't know why, but this is what I'm interested in, is using it for quick builds or projects. Just load the container. It takes seconds to load the container, then run the job, grab the files, close down the container, and that way I'm not storing directories of stuff on the host system. It just, for me, it's going to be better organization, and the fact that I can run the Slackware ARM operating system after a fashion, and I'll explain that in a bit. The fact that I can run the Slackware ARM operating system in a container is an added plus, because it's OS level application containers, but not quite the full OS. You can't run init, for example. It has its own Docker init system which takes control and seems to be very effective. I don't know too much about it, but it works.
So the stuff you showed me this morning I've never seen that before, because I've only got the Docker desktop on a Mac. So all of that stuff is I've just followed someone's instructions and installed it. So I've not seen the Docker interface until now. From what you were just saying about init, it makes sense, because of what you showed me about, was it if you run Docker as root and then you get root access on the Docker container, you've actually got access to the host system as well. So you could cause the entire host system to reboot by just echoing B into proc this RQ trigger.
Yeah.
Yeah, so I didn't know about that, but that's interesting, because now it makes me understand more about how Docker's built, about it's architected, which I think is actually quite interesting. I mean, it also explains why, to some degree, what gives me an impression about why you don't need to run the init, because it's not a virtual machine.
No.
So,
no.
But I think which I think is really interesting, actually. I do. I think so I interrupted you there.
I found out about being able to affect the host system by accident, and one time when I'd finished using a container, I actually typed init 0 just to see what it would do, and then the whole screen shut down, and I went back to my previous system that I'd SSH'd in from, and I'm thinking, what the hell's going on here? Because it not only closed the whole system, the host system, not the container. And I thought I should not have been able to do that. However, I went investigating and I read a blog where somebody explained it really well and said, look, you should never run a container as root, because if you are mounting volumes from the root system, the host system, you can affect it. And other commands which you can use as root, such as the one you've just mentioned, the sysrq trigger, you can affect the host system from within a container. So that's why you never ever run containers as root. And there's all kinds of implications for permissions and user rights and everything else that should not be invoked as root for that reason.
Okay. You're not supposed to run the Docker itself as root.
Yeah, you Docker, the Docker daemon runs anyway. Docker daemon runs like any other daemon. But when you invoke, when you want to create an image, when you want to build an image and then run the container with the image you've just built, you must do it as a normal user.
Okay, that makes sense, because if the Docker container was compromised, then it would equally just be compromising the host operating system anyway. So yeah, that makes sense. Okay.
Yeah.
So it goes back to, I think, in terms of what you're going to distribute and how you're going to set it up, it goes back to what it is, what the actual intention is. So what are your thoughts at the moment then? What kind of direction are you taking it?
I want to create a mini root file system that's got SSH enabled, and that you log into just like you would log into any Slackware ARM system. You get your login prompt, your username, and you put your password in, and then you're there. Because I want to be able to make this available to the general public, for people, especially for people who don't know what Slackware ARM is, who may have used ARM devices with other operating systems from the year dot, and suddenly they come across Slackware and, well, why is Slackware different? Well, it's the oldest of all the Linux distributions, and it's just about the only one now that sticks to Unix standards and traditions, because I'm not that familiar with all Linux distributions, but they all seem to be swaying from the target and wandering off the beaten track, shall we say. So Slackware is attractive to those people who are interested in the standards and traditions that Unix had.
Okay.
It's not pointy click. You will not get X, as you said earlier. You won't get any of the X applications, desktop or anything like that to run in a Docker container. It's purely command line. So
this is the thing, right? This is where I'm currently not seeing why it would be interesting to people through a Docker container. I'll tell you why. It's because the way I'm looking at it is that because the way the Docker containers are basically appliances, in the way, like, it's just, here's another toaster. You basically, normally you'd give somebody a container and it would have, like, the example I mentioned on the previous podcast. I've got a Docker container for that my company's provided out there, and it happens to run Ubuntu because whoever made it likes Ubuntu. So it's fine by me though, because it's got a bash shell, and it means I can easily just code or script things up and start using our tools. And they've included the vendor tools inside the Docker image, so I don't have to really do anything apart from just create a bit of config to tell it what to do. I mean, I can script that up. So I'm not interested it runs Ubuntu whatsoever. I know it does because someone told me, but I wouldn't, unless they actually said this runs Ubuntu, I would have never have known. And I wouldn't have cared to check, right? It's just, here's a bash shell, great, it's bash 4, good, I'll do my stuff, and then close it. It's a utility. So you're not going to, whereas if you want to look at Slackware, you're going to look at it from the operating system point of view. You're either going to, you're either going to want to use it as an operating system because you like the way you like the style, and you like the way you can interact with it, you like the way you can build on it, and you like the way you can get hands-on. And the Docker container of Slackware would be a byproduct of something you've worked on, rather than, do you see what I mean? That's the way I look at it. I don't know if that's what, if you see what I mean, but you wouldn't approach a Slackware through a container because it's like, well, it's just another, you're not really getting to see the distribution. You're not going to really add users and then start running services on it, because the whole point is you've built something in the first place, and here's the container, and it does what I've told it to do. You've set it up to be a certain way. It's like a deployable, it's configured to do a particular activity, to do a particular thing. Okay. Which is what the point of them, that's what they're about, right? You've got a container for certain types of services. For example, you might, containerize a particular service, like an FTP server or email service. You just say, right, here's the container, it's all set up to go, and I can deploy it anywhere I like, and it will just start working. It will use shared network drive services, or it will use for storage, or we write to a network aware database or whatever, MySQL. So that's the understanding I've always known or have of these types of things, but I see them as being useful. This is why I'm asking you. It's like, if you look at the mini routes, the audience of the mini route was me, right? So I just, it was a developer wanting to go and make it easy to just get a working operating system and just unpack it onto a target drive and boot it, rather than our syncing a live operating system /dev/SDA was in use, or this file was locked, and all these kinds of things. I just wanted something that was clean and fresh, and I could just put it down, get it booted, and start working on it. So the audience, or the target, was very well focused. So the output, it tells you you've got the login, the root password is this, and that's it. Right, there you go. You don't. If you want to upgrade it, then you can do so if you want, or if you need to do that. Whereas in your case, it's not like that, because people aren't. I don't see the mini root is a base to get going, which is what you've taken a mini root and used it for something I never would have thought about. I would never have thought someone would make a container out of the mini root. It wasn't on my plan when I sat, years ago, scripting it up.
Yep.
But in your case, I think it's more about, I would say, what are you gonna, if you're gonna use the containers to say run services on your home network, or the stuff you do as the other projects, then it kind of makes sense, because you're saying, right, we're going to run a Raspberry Pi is going to run these services, and we're going to run the the blah blah blah, so the FTP server in this container, the email server in that container, and this is how we're going to you've written all the scripts to do it, and then you say this is how you can run Slackware. You can run servers, daemons in Slackware ARM, and if you want to, you can have a Slackware ARM server. You've got a 2 gigabyte RAM Orange Pi or something, or Raspberry Pi, whatever you've got. And if you want to containerize certain applications on your home gateway, you can run Docker, and here's how you can do it. And here's a mini root and stuff like. So you could and so the Docker container itself is like a separate project, if you see what I mean.
Yeah.
It's because it's not the Raspberry Pi project either. It's Slackware ARM in a Docker container. It's not actually anything to do with the Raspberry Pi. I could take your Docker stuff and run it on my Orange Pi.
Yeah.
So it's not Raspberry Pi at all at this point. It's actually Slackware ARM in a container.
Absolutely.
So, which I think it's a really good idea, as long as you kind of got the, what's the interest, or why should people care? Why should they look at it? That's always the key thing, if you see what I mean. Because I know you're interested in the tech, you're playing around with it, right? But when you're putting it out there, it's kind of like, what are people going to do with it when they take it? People want to see use cases and things like that.
There's a lot of people that I speak to who either they've got an opinion about Slackware having not used it, or they've used it and it's too hard, too old, and too much effort. And I want to create a Docker container, just as you've been talking about, not for the purpose of running an FTP server or a mail server, but for actually running the OS in Raspbian or any other ARM-based Linux operating system that can run Docker. And that way they could start up a Slackware ARM container and just use it. Add their own users, configure an Apache server, configure a mail server, do whatever they want to do, because within the container there's very few limitations that I've found with regards to running services, processes, things like that. It's more the interaction with the host OS that's the limitation. So there are a lot, and when I say a lot, I'm understating myself. There are a lot of possibilities with using Slackware ARM container, especially if you're wanting to get a feel of the operating system. If you're used to Ubuntu or CentOS or anything like that, Slackware is not like that. Slackware is very hands-on, and if you want to get a feel of how much more effort and time, or even for a project, if you wanted to compare projects between Ubuntu and Slackware ARM, you could do that within a Docker container without any impact on the host OS whatsoever. So the target audience there, for people who are developing or just want to test or play around, the target audience I should imagine should be quite broad.
Okay, I get what you're saying now about the user base and the target audience, and it brings me back to our previous conversation in the last podcast, where we were talking about the size of the mini root, and well, rather not the size, the content of the mini root, but also the size, because obviously it's related. And well, the mini root was designed to just get new ARM target systems bootstrapped. So it's got enough networking support to be able to download the packages and get bring in the compilers, bring in the extra packages. But you did some work on this already, didn't you? And you ran Slack package inside a container, didn't you, to see how long it would take to update the container?
Yes.
Or how long did it take?
Slack package on a full install with absolutely everything, including kernel source, is just over 2 hours.
Right. Okay.
If you download the Slack package, Slackware directory from a mirror using rsync, and then install all packages, it's about an hour. So the differences between using Slack package and install package, like you find name *.txz exec install package, all of them. So just go through every txz in the Slackware directory and install it is an hour.
Okay. So yeah, this has got me thinking, you see, because if you want people to see what Slackware ARM is like in a container, which they could do so, you've got, you showed me earlier, you can either, bring up the login prompt and people can log in as they would a normal system, or they can run \l and get a root shell immediately. I think that maybe you do need to provide a fully installed Docker container, because, if people are going to want to start playing around with it, you've got everything to offer straight away. Whereas with the Vini root, they're going to have to wait. They're going to have to update it. It's going to take a while anyway. And it's easy. It's much faster to just spin up, download an image and just run it than it is to update an operating system, as you've found.
Yeah, and the difference is there. This is what I'm toying with at the minute. The difference is there is that the Slackware ARM mini root is about 75 megabytes, and a fully installed system with all packages is about 12 gigabyte. And an image without X and everything to do with X, you're looking at about 6.5 gigabytes. So, these images are quite large.
Yes.
And maybe I would be willing to, because I'm into Slackware ARM anyway, I'd be willing to wait that length of time to download and install the image. But
No, but people are. I mean, if you look at, say, some of the Fedora images, like the desktop spins and things like that, they're gigabytes in size already. So people, it's not an issue really. I mean, it doesn't take that long to download. Even on I only get about 25 megabits a second downstream at home on my ADSL. It's supposed to be 45, but that's what happens in the UK. You pay for 45, and and you don't get any reimbursement for the fact that you can't get what you're actually paying for. Anyway, yeah, that's how it works in the UK. But you've got much faster than that, as I saw earlier. So it's not really an issue, I don't think. And there's not, and most people have got lots of spare disk space. Maybe not on a Raspberry Pi, but even so, it's not like unless you're running off a micro SD card, okay, then all bets are off. But if you've got, like I have, you've got an SSD or USB caddy or something, you can easily plug it in and you've got terabytes or gigabyte. I don't think it's really that much of an issue. It's more about just the uploading, but even then it's going to take you a few hours to upload it, and as long as you don't upload it every day, it's probably. And the thing is, you don't need KDE, for example. You could cut that right out, out, because you don't need that. Nothing is linked. In fact, in Slackware ARM, KDE is the last thing to be built. So everything else in the build system, when the packages are being updated, everything, including X, gets recompiled thrice. And in the case of X, it actually gets recompiled. Hang on, how does it? 6 times. Everything in it, because it gets recompiled. There's a loop inside X that rebuilds X inside a loop of the main parent loop of the build system to try and make sure that everything works. So X gets, but KDE only gets built once because nothing else is depending on it apart from KDE itself.
Yeah.
So you could cut KDE out, and you could also cut the kernel source out, the kernel source package, because, well, people aren't really going to be. Generally, the only time you're compiling something like that is if it's actually the host operating system, right, where you need to build something that happens to need to know about the kernel, the running kernel.
Yeah.
And so you're not going to do that in a container. I can't imagine that anyone would. And if they do, well, they can install it. It's just a Slack package away. It's just a install package away. It's not it's not the end of the world. So I think you can, and you can cut the Linux how-tos out and stuff like that, and you just put in there it's a full installation minus these things. I think and that's what I would do, because you can strip the distribution down a bit. Yeah, you cut out TETX, for example. You probably don't need that either. I'm not sure I'd cut out XAP, because things like Image Manager are in there, and some of the packages link against them. So I'd probably leave that in there. And you might need X11 as well, because PHP is built against some of the X11 libraries. So you'd probably want to leave all of X in there. But so, for example, you could cut the fonts packages out. You probably don't need those.
Yeah.
But so there are some things you can do, and I think there are some things you can do, and you can just script all of that and just put it into a. You could even say you don't even need to document it, because the script's self-documented, like the mini root. I don't tell people what's in it. I say, go look at the script. All of the packages are listed out line by line in there, and you can look at it. So I don't think if you want to go that way, I think that's a pretty good idea, because people will be able to see, they can download the container, run it really easily. They don't even have to install it.
I will look at the Fedora images and see. I'm going to download and install them just to see what they are and what's going on.
I think your idea is good, and I think you're probably going to need more than the mini root. I think you should probably just do what the mini root does, but install, instead of selecting individual packages, just select package series. So the mini root can easily be adapted to do that.
Yeah. And
then just so you don't include KDE, don't include kernel source, so don't include the K series. Maybe don't include. Well, I was going to say you can exclude Emacs. If you do need that, you can exclude Emacs.
TCL.
TCL, things like that.
Yeah.
The FAQs and some other stuff, but you could leave the rest of it in, because that's going to reduce it down to a pretty good. Well, it's still going to be big.
It's about 6.5 gigs without X.
No, you need X. You need X because PHP seems to get it.
Oh, right.
Well, no, because XAP has got Image Manager. That's one of my company's products, Image Manager, Image Magic, and other things. So there are things in the XAP, because this is the thing about Slackware. It used to be that the libraries series was libraries, but now things actually Image Manager might not Image Magic. Maybe it is in the L series now. It used to be in XAP. I can't remember.
Yeah.
But anyway, my point is that there are things, there are packages in different series which are linked together, and so that the dependencies are there. But you could easily get away with removing KDE and TCL FAQs and stuff like that.
Yeah.
And maybe the font packages, don't install those. You wouldn't need those, I would have thought.
I'll take out whatever cannot specifically be used.
Kernel firmware, take that out. That's quite large. You don't need that.
Yeah, the kernel stuff.
You don't need the kernel firmware for a Docker container.
I needed to, in order to build SARPE in the container, I needed the headers. But that's just individual subjective requirements. What I think we're discussing here is the general overall best possible state that it could be for a new user to use.
Yeah, because it's not SARPE, it's actually Slackware ARM in the container.
It's Slackware ARM.
Not a Raspberry. If you happen to run it on a Raspberry Pi, that's fine, but you could also run it anywhere else.
Oh yeah, everything involved is your work. It's the mini root and the packages. It's all your work. There's absolutely nothing that we're putting into this that we're designing specifically for the purpose. I want it to be as close to Slackware ARM as it could ever be, and without any additions at all.
Okay. Well, if you want to have a look at the mini root script, I know you've looked at it. If you look at the build script for that, then it can easily be adapted to make a big root. If you want to make some diff, if you want to give me a diff, I can take it in there and just put it on the website, and people can
That is
FTP
a
side.
masterful idea. Why
Big fat
didn't
root.
why didn't I think of that? Yeah, that is a very good idea. Thanks for that.
Yeah, it's not. I mean, I would do it myself, but I don't need a big root. And here's the thing. I mean, I could easily do that. In fact, the mini root build system, not that, rather, in fact, the mini root is updated every single time there is a package in the package change list that's got built for ARM. So it scans the package change list, and then the build system checks the list and sees any of those checks whether any of those packages are in the mini root build script, and if they are, it goes and rebuilds the mini root every time. So the mini root for occurrence is always up to date, unless I manually stop it from doing it, which occasionally I do actually, but not normally. But I don't mind that because it's only a few hundred megs in size.
Mm-hmm.
Whereas if I can't be uploading 5 gigs for every time I push out an update to current.
Yeah.
So that's why I'm not going to do it myself. But I can, I can take any diff and put it in the mini root build script and just stop calling it mini root and just take it an option, call it root build script and just take an option if it's mini or it's big. I don't think it's not a huge, because that way you'd actually get you'd actually end up with the root file system set up in the same way. And that way you can have a standard MOTD and all that sort of stuff because you wouldn't need to tell anyone to update the container. It's just this. Because, because you wouldn't have, I mean, let's look at that. If you think that's a good idea, I think you can think about that one. If you think it's a good idea, we can do that. So I appreciate that you want to keep it the same as as close to what I've done as possible.
Absolutely.
I think that would certainly help do it. And then if you want to maintain that, that's not part of SARPI anyway. It's a separate thing. And you can, if you wanted to, I mean, we can speak to Darren and see if you can upload it to the FTP side, because there is a way of doing that. I've got someone else did that a while ago. And then you could maintain it in there, and then you can just update it every.
I think the first thing I'll do is as you suggest, look at the mini root build script and just add whatever needs adding to that. Make an image out of that and then use that, because it's going to save time and confusion in initiating and executing the container. Yes,
it will. It'll make it more simple, and it is only a few gigabytes extra.
Yeah.
So it's probably, and actually that is making me think it's quite interesting, because if it was a full root, it would be quite interesting actually. Because if I wanted to, for example, if I was going to mess around with some of the things in Slackware ARM, it's easier to do it in a container and just faff around with it and play around with it than it is to go and reinstall the machine afterwards, after I've completely just allowed it to splatter itself, which is what I do at the moment. I just reinstall the machine.
Yeah.
I've got several, I've got enough machines to do that, but
yeah. Well, I usually create an image of a running machine, and that image is the size of the SD card. So I've got 10, 20, maybe 30 images all on a hard drive. Some of them are 64 gigs in size. And using a container, you won't have any of that size to back up or store, because everything's temporary, and images can be saved. If you've got a container image that you're running a project in, you can export that to a tar file or a gzip tarball, and then just import it next time. So it's very usable in that respect. You certainly don't have to go reinstalling the whole system, which takes hours.
Yeah, I think it's a good idea. Yeah, if you want to make a diff of that, if you want to work on the mini root on the mini root build script, you can have a look at that.
Yeah,
it's a good idea. Oh, cool. All right, well, that's really good, Phil. So let's leave it there, and we'll pick up next time when we've made some more progress on it. Cool. All right. Well, cheers then, Phil.
You're very welcome.
So this is the end of Slack Chat. So that's the end of Slack Chat episode 5. What am I talking about? So this is going to be the end of Slack Chat episode 12. Tune into episode 13 to see what we've got next. Right, so that's bye from me.
And a very good bye from me.
Goodbye.